Today's lesson is the second part of section 2.3, and we're going to be concentrating on maximum, minimum values and the average rate of change. So I'm going to go ahead and just start with the mathematical definitions, and then don't worry if it sounds super confusing. I will break it down for you as to sort of like, okay, what does all of this mean? So it says a function value f of a is called a relative minimum if, hang on, I better start. So relative there we go, of f if there exists an interval x of 1, x of 2 that contains a, which is just a number, such that f of a is less than f of x. It also holds true that a function value f of a is called a relative maximum of f if there exists an interval x of 1, x of 2 that contains a such that f of a is greater than f of x. Okay? So what that means is think about our area. There are maybe not so many mountains in Greencastle, but there's definitely some hills and valleys. So let's concentrate on our hills for a while. So think about even just in your yard. Are there any hills in your yard? If you have a sand mountain, well, that's a little bit of a hill. That might be the highest area in your yard, but it might not be the highest area in Greencastle. The highest point in Greencastle, it's high for our area, but it's not the highest point in Cumberland or in Franklin County. And then even that highest point in Franklin County, it's not the highest point in the entire state of Pennsylvania. And then the highest place in Pennsylvania is not the highest place in the United States or the world, so on and so forth, okay? So if we scale it back down to our area, we're thinking, okay, we know there's higher places, but locally or relatively, these are the highest points. So that's what we're looking at for relative max and min. You're going to see in the graphs here below that it's also called local max or local min, but it's all the same thing, okay? What they mean by that interval f of a. So if I'm looking at my whole graph, which is this one, we can see the local max and mins, even for just this part of the graph, because I've already taken a small piece. Okay, I'm not showing you the entire graph. But then if I look over on this side, I'm narrowing that graph even more to just this little yellow part here. Okay, that's my interval. And A is this point right here that happens to be the highest point in that little slice or that interval that we're looking at. So that's what they mean by local or relative max or mins. All right, so fortunately for you, this should be somewhat of a review from Algebra 2 because you guys did find max or min values in Algebra 2. So it says approximate the relative maximum or minimum value of this function. So first thing we have to analyze is what type of function is this? So I'm looking at it, I see it's quadratic, so that means we need to remember some information about quadratic equations. Quadratic equations, remember, they're of the form ax squared plus bx plus c. That a value is going to give us a lot of information. So if a is positive, meaning it's greater than 0, my graph opens up. Okay? If a is less than 0, meaning my a value is negative, my graph opens down. Okay? If it opens up, my graph looks like this. That means that vertex point is going to be a minimum value. If my graph opens down, that means my vertex point is going to be a maximum value. Okay? So in other words, we are just trying to find that vertex point. So hopefully you remember how to do that from Algebra 2. If you do, that's great. This is going to be review. If not, no worries. We're going over it now. So the first thing we need to do is find the x coordinate of our vertex point. So to find that x coordinate, maybe I should write that down. Really, this is our only step, is to find the vertex point. Okay, so to find the vertex point, it's x equals negative b all over 2a, if you remember that from earlier in the year. So looking at our equation, our a value was 3, our b value is negative 4, and our c value is negative 2. So we get negative b all over 2a. So we get 4 over 6, which reduces to 2/3, which is approximately 0.6 repeating. Okay? But just finding that x value is not enough because we need the max or the min. Okay? The x value tells you where it is, left to right. The max or min value, that's your y value. It tells you how high or how low you're going. But we want the entire ordered pair. Okay? That way we know where this max or min is located. So now we have to find the y value, or the f of x value. I'll be consistent with the f of x. So now we have to find f of 0.67, or you could do your 2/3 if you substitute that in. All right, so if you go through, do all of this work, square the 0.67, multiply by 3, subtract 4 times 0.67, and then subtract 2, you get negative 3.3 repeating. So that means our ordered pair is 0.67 repeating, comma, negative 3.3 repeating. But we're not quite done. We need to know, is that a maximum value or is that a minimum value? So we look at our equation and say, hey, A is positive, so my graph opens up. And since my graph opens up, that means my vertex point is a minimum. And now we are finished. All right, so take a moment, pause the video, try this your turn. Come back and see if you got the right answer. All right, I'm also going to write down the steps that you can do this in the graphing calculator. And then I will show you. Maybe I'll do the your turn with that. Okay, the second step, locating that max and min on the screen, is super important. If you can't see it on the screen, the calculator won't be able to find it for you. And a lot of these steps are very similar to what we did in class for zeros. So we're going to type the equation y equals, maybe I should put here like zoom 6 typically to give you a standard screen, and then you can zoom in or zoom out from there. Second trace, we want number 3 or number 4, depending on if you're trying to find the max or the min. It is going to say left bound, just like it did today, with a question mark. You move your cursor to the left of it and hit enter. And then it's going to say right bound. And then again, you move your cursor and then hit enter again, and it will give you your answer. All right, so I'm going to type this one in. So negative 2x squared plus 4x plus 3. I'm going to graph it. If I couldn't see it, I could do zoom 6. All right, now I'm going to hit second trace. This is a maximum because it was my highest point, so I'm going to do 4. It says left bound. Well, right now I'm on the right-hand side, so I need to move my left arrow to there, hit enter. Now move my cursor to the right of my vertex point and hit enter. And there's my ordered pair, 1, 5. Okay, moving right along to average rate of change. So average rate of change, if you remember from Algebra 1, it's really just another name for slope. Okay, because it says between any 2 points, x comma 1, or x sub 1 comma f of x sub 1, and x sub 2 comma f of x sub 2. Remember, that's really just x1, y1, and x sub 2, y sub 2. Don't let those f of x's confuse you. It says, is the slope of the line through 2 points. The line through the 2 points is called the secant line. Okay, and the reason we're finding the average rate of change, even though we have 2 points, is because most of our functions are not going to be linear. So if they're not linear, that means their slope is not consistently the same. So we are finding a slope. So if this right here is my graph, I'm averaging, if I use this point here and this point here, I'm averaging that slope. I'm really just finding the slope of this straight line right there. Okay? And that's sort of averaging all the slopes together across this interval. So let's take a look at this. Oh, there's the formula, but don't forget, the formula is just y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Again, don't let the function notation confuse you. It says the average rate of change of f of x equals x cubed minus 3x from x sub 1 equals negative 2 to x sub 2 equals 0. We got to find it. So I'm going to write down what they gave me. They gave me x is negative 2. Oh, and then they gave me another x. And that x is 0. So what we're missing are the y values. So I can find them, no worries. I could find f of 2. Okay, substituted this value, I want to do negative 2, into the function. There we go. So negative 2 cubed is negative 8. Negative 3 times negative 2 is positive 6. So we get negative 2. So f of negative 2 happens to be negative 2. All right. Now let's find f of 0. So 0 cubed minus 3 times 0. Well, wouldn't you know it, we get 0. I will tell you this does not always happen. We don't always get the same y value as the x value. Just happens to be a coincidence here. So now to find the rate of change, I have both my ordered pairs. So I'm going to do 0 minus a negative 2 over 0 minus a negative 2. I get 2 over 2, which is 1. So my slope is 1. Or my rate of change, my average rate of change. All right, last example, sort of applying this. Where would I see something like this? It says the distance s in feet, should say of a moving car, the distance s in feet, a moving car is from stoplight. Oh, that sentence is horrible. So the distance s in feet of a moving car is from a spotlight is given by this function, s of t equals 20t to the 3/2 power, where t is the time in seconds. We have to find the average speed of the car from t sub 1 equals 0 to t sub 2 equals 4 seconds. So how fast is this car moving in 4 seconds, in feet per second? So let's look at our ordered pairs. All right, again, t is my x value. S of t, I guess we'll use s there is my y value, even though that's not correct. Okay, so our x and y. So we have 0, and then nothing, and then 4 seconds. Okay, so again, we have to find our y values. So if I keep wanting to do f. S of 0. So that's 20 times 0 to the 3/2 power. We get 0 again. Again, coincidence, but in this case it makes sense because if we didn't start moving yet, we're still at 0 feet. We have gone no feet yet. All right, so now to find S of 4. This is after 4 seconds, so I better have moved a certain number of feet. So 20 times 4 to the 3/2 power. That means I'm going to take the square root, which of 4 is 2, cube 2, that's 8. So 20 times 8, woo, we went 160 feet in that 4 seconds. So now we can find our slope. So we're going to do 160 minus 0 over 4 minus 0. So 160 over 4, we went 40 feet per second. All right, so you guys have 2 your turns to try. I'm just going to jot down the answers, that way you can check your work, and then we are good to go for today.